Hi class, let's take a look at example 4. Now, problem 4. Now, on problem 4, um, in order to determine if the equation is given as a function, we need to solve for y. So that should be our first step if it's not already solved for y. So let me just write it as solve for y. Remember that you're expressing these as f of x. So you currently have x is equal to y squared. In order to solve for the y's, you would take the square root of both sides. Now, remember what happens on the property when you take the square root? You end up with a plus and minus square root of x is equal to y. So as we completely isolate this one, and let me flip it, you would have that y is equal to plus and minus the square root of x. Now, here's the problem. If you were to graph this equation as it stands, and let me use two colors, this portion here, it's going to represent your y is equal to the square root of x. And let me use a slightly different color. This starting at 0, it's going to represent y is equal to the negative square root of x. So not only you technically have this structure, when you draw the vertical line test, or actually it's supposed to be like a dotted line, and we apply the vertical line test, it fails. And it fails because of the nature of the x is equal to y squared. So in this case, you end up with two equations. If you separate them, they would represent functions, but together, they're not a function. So in this case, we would simply say, no, x is equal to y squared does not pass the vertical line test. Hence, x is equal to y squared is not defined as a function. Okay, that's it for this one. So you do have to remember to solve for the y's on all of these, and then technically look at their sketches or find coordinate points that fails. Remember that if they're defined as functions, y represents f of x. And this is from the definitions. Let me just go to the definitions. And that's what is referring to this portion here. So all of your equations need to be solved for the y's. Okay, that's it for this one. Let's move on into 5. And here's the problem with 5. So if you express this one in terms of the actual, in terms of what it represents, this one represents the equation x squared plus y squared is equal to 3 to the second. Or another way to express this one, it's technically a circle of radius of 3. So technically you would have 1, 2, 3, 1, 2, 3, and then 1, 2, 3. Now to scale, this one represents a circle. And then within the circle, wherever we draw the actual vertical line, it's going to fail. So we would simply say on this one, no, x squared plus y squared is equal to 9 is not defined as a function because x squared plus y squared equal to 9 fails the vertical line test. And that's it for this one. It would be the same approach if you had solved for the y's. You would end up with a plus or minus, except that this one fits the equation of a circle. In this case, it is not defined as a function. Let's move on to 6. In 6, we can isolate the variable. So same idea as the first one that we did. So we're gonna solve for y, and we're looking at x is equal to y to the third. So in order to cancel the y to the third, we're gonna take the cube root of y. So we're gonna end up with the cube root of y, cube root of x is equal to y, or y is equal to the cube root of x. Okay, in this case, let me provide the sketch of this one. As you graph the cube root, this one's gonna have this basic shape. So it's gonna go to the right in this direction and then this direction. And then notice that if you draw a vertical line, this one's gonna pass. So we would simply say yes, x is equal to y to the third is defined as a function since x is equal to y to the third passes the vertical line test. Now, let me pause the video for a moment and I'm going to use technology to show you these 3 graphs. Okay, so I did this for problem 4, a basic sketch of what it looks like. This is x is equal to y squared, but let me show you what it actually looks like to scale. And that's going to be this graph. So you can see here, well, you have one piece and then the other piece, it's going to fail the vertical line test. Let me just put an x is equal to 2. Actually, I put 3 by accident. And then you can see it that it's not going to pass. So here you can see the 2 coordinate points where it fails. We only need 1 for it to fail, and it's not defined as a function. That's the sketch that I attempted to do here. In any case, x is equal to y squared. It's not defined as a function because, well, you're going to have a single x giving you multiple y values. And let's take a look at problem 5. Problem 5 was x squared plus y squared is equal to 9. So in this case, it's going to look like this. As you can see, it's a circle. Let me make this smaller to 2. And this one is defined as a circle, and you just need one portion for it to fail. In this case, I picked up 2. You see the 2 intersections. The sketch, I just picked anywhere on space where it fails, and it's supposed to be a vertical and also dotted. So I missed that part of the dotted. Let me just rewrite it. But this is supposed to be a dotted line. Okay, there we go. And let's take a look at the last one. This is x is equal to y to the third. In this case, that's what your y to the third looks like. Let me select a different color. In this case, blue, and you can see that, well, anywhere in space, you're just gonna have a single intersection. We don't have that a single x gives you multiple y's, which is what we did here. This is the sketch. I just put a dot there, and this one, yes, it's defined as a function. That's it for these 3 problems. They do require that we remember what basic graphs look like for determining if these mathematical structures are defined as functions. Remember, It is defined as a function if every x has a unique y value.